Hi, I'm Franciscan Boy,
And
this is Just for Funk.
Hi, and welcome to episode number 37 of Just for Funk. Today I'm in Barcelona at my parents' house, and I actually was recording something, and I was recording with a drone over the pool where I was hanging out, and I decided to ask people on Twitter with that video, hey, I'm hanging out by the pool, what should I make the next episode of Just for Funk about? And someone told me, hey, you're hanging out by the pool, why don't you make it about sync.Pool? Which is an amazing idea. So that's what we're going to be doing today. We're going to be learning about what is sync.Pool and why would you use it and how you use it and why sometimes it's not necessarily the best thing to use. Does that sound fun? Let's get started. From today's episode, I already wrote some code to prepare it, and it's something that I took directly from a little GitHub bot that I wrote a long time ago, and it's something that receives GitHub webhooks. So let's see the code first. So it's a web server, so it's very simple. And for anything it receives, it just calls the same thing over and over. And what it does is it decodes the payload from the GitHub notification, which is actually this pull request event that has like a pointer to string, a pointer to int pull, a pointer to a pull request that has more things inside. So basically, this is what you receive every single time that something happens on a pull request on a repository where this bot has been installed. If you want to check out the code for the whole thing, is under github.com/campo/goodgopher, but this is enough to understand what I'm doing. So we decode the body, and then we decode all of that into the data, and then if something bad happens, we log it and we do HTTP error to notify GitHub about it. Otherwise, we print the ID of the pull request that was modified. So that's pretty much what all the code does. Only 25 lines of code. Spend some time reading it. It's as always on GitHub, so you can go check it out, github.com/campo/justforfunc/37-sync-pool in this case. But you'll find it there anyway. All of the source code of GitHub Just for Funk is always there. So just to show you that this works, this is an example of a pull request that you could receive. So this is the example actually from the documentation. So what you could do is you could run the server, and it doesn't work because I'm running already something. Who's port 8080? So let's kill main. Okay, go run main.go. Okay, so now the server is running, and now what I'm going to do is if I'm able to remember how to do this, I think you can do x post data test data payload.json http localhost 8080, and it worked. Cool. I'm actually pretty surprised that I remember how to do a curl request. But anyway, so that sent a post request to the web server behind localhost 8080, and the data in the request was the content of this file. So we have all of that. There's a lot of data in there. Anyway, cool. So now that we have this, I also wrote a test, which tests, they're good. So in the test, you can check the code. There's actually an episode about how to test web handlers, HTTP handlers. So basically I did that using, basically the most important part is I'm using an HTTP test recorder, which allows you to basically send something that you can record the response that you're gonna get, and then get the response directly by doing rec.result. So this is a very useful thing. The interesting thing though is not the test. The test is just to make sure that it works. The interesting thing is that I also wrote a benchmark. This benchmark, what it does is it reads the file once. Since I don't want to measure how long it takes to do that, I stop the timer first. I read the file, and then n times what I do is I create a new request, I create a new recorder, and then I start the timer there, send the request, stop the timer, right? So basically what I'm trying to make sure is that I only measure the things that matter to me, which is actually the part of executing the handle function. The rest, I really don't care. Cool, so now that we have this, how do you run this benchmark? Well, it's pretty straightforward. Go test-bench dot. So if I run this, let's put it there and make it a little bit larger. And remove this part so you can see it better. Okay, so Cool, so this takes some time, but this is actually not that useful because actually what I care about is how much are we allocating. We're gonna be talking about sync.Pool. So benchmem, that will also do a benchmark of the memory. So now this told me that we're allocating 883 allocations per operation, which is a lot, but at the same time, it kind of makes sense because you're allocating, basically, you're creating a new, let me show you the code. So you're creating a new object here, the GitHub.pull request event, which has a bunch of pointers, but then you're decoding everything in there, which means that you're allocating extra things every time. And that is 94K, more or less, 94K that you are allocating. So is that good? Well, I mean, it's a decent amount, right? But the thing is that maybe you could do better. Before we go into how to make it better, let's talk a little bit about what sync.Pool actually is, right? So the idea here is that we're allocating a new object, a new GitHub.pull request event, one of these pieces of memory every single time, right? So you could say, well, maybe we could reuse it. So you could do something like this. You can move this data here. Now, if you do this, this is an awful idea. Why? Think about that for 2 seconds. By the way, today I was told that if you ask people to wait for, to think about something during a video and then you shut up, that's actually infringing a patent, I've been told. If that's the case, I'm sorry, please let me know, I'll stop doing that. Anyway, so I hope that you had the time to think about this. Why is this a problem? Well, because if you have 2 requests at the same time, you're actually decoding 2 different payloads into a single variable, which is an awful data race. So bad idea. This is not a good fix. Cool, so we put it back here. What is another option? Well, what if you had a bunch of these pull requests that are ready for you to consume, right? So you could maybe, this is an option that I will not be writing the code for, but you could think about that. You could probably use a channel, right? If you have a buffer channel where you put a bunch of GitHub requests, and then what you're doing is every single handler gets a new one. Every single time you execute, starts using it, and then once it's done, it returns it back to the pool with some options of if nothing is left, maybe you create a new one and then you don't put it back, or maybe if you put it back and everything is full, you just drop it. There's a couple options, so check it out. It's an interesting idea. Try it out. If you're really interested, let me know. Write a comment write a comment right here on the bottom, and I will definitely do it. But let's assume that you understand what the code would do, right? Basically, you have a place where you're putting objects that are ready for you to use later on. Well, that's what sync.Pool does. That's basically what it does, right? There's a little bit of a difference though, because sync.Pool at the same time has a better understanding, since it's part of the standard library, of how the garbage collector works. So it is much faster than using that solution with the channel. So this much faster solution and also much simpler. So let's think about this for a second. How would you use it? Well, basically what you need to do is, rather than having that variable that we saw, like moving this pull request event outside, what you're gonna move outside is a pool, sync.Pool. So let's call it pull request, pprof is sync.Pool. And what do we write in here? What does a sync.Pool have? Well, a bunch of things that are actually not exported, so you don't really care, but it has new. And that one you need to give it is, how do I create a new one of these things, wherever they are? So, whoops, I'm writing in Chinese. So new is gonna be a function that returns an empty interface. And in this case, you're gonna return a pointer to a GitHub request. Whoops, one of these. And a comma here, comma, there you go. Okay, so now, rather than creating a new one, what we're gonna do is, we're gonna request a new one. So we're gonna do, so data is going to be pprof.get, and that returns an empty interface, and we wanna use it as a pointer to a GitHub pull request event, right? So we're going to do a typecast, which looks like this. It kind of looks like a function call, but it is not. The difference is that that dot in there, right? So that dot and then parentheses, that is the syntax for typecasting. If for any reason the empty interface that you got in here was not a pointer to GitHub pull request event, that would panic. If you don't want to do that, then you could use something, comma, okay, and then rather than panicking, which return false in the okay and nil in data. But that's something else. Well, nil or whatever the default value for the type you're transforming into, you're casting into. But let's delete this because I know that it will always be a pointer to pull request event because I'm the one that wrote the new function. So we do that. And then what else do we need to do? Well, we need to drop that because this is already a pointer. We need to not drop that because ID is still a pointer. So that's why we're doing it. And we're missing one more step, which is once we're done, as it said, like you're getting one more pull. Once you're done, you want to return it, right? So defer pprof dot put, and you put the data. So you give that pointer that you just got, you give it back. That's it, right? So that's it. That's everything you need to do in order to get a sync.Pool working in your web server. Now, does this actually help? Well, let's see. Okay, so I created a perfs.txt file where I'm gonna be keeping all the performance of the things, so to keep track whether it's improving or not. So I'm gonna start with the first one, which is github.pull request event no pull, and this is the performance. Let's make it. Actually, I don't really care about this part, so just keep that part. So it takes 500 so nano micro 500 microseconds. 94K are allocated per operation, and that is 883 allocations total. Let's run it again now that we've added that pull and see what happens. Cool, so I'm just going to copy this and put it here. Second, GitHub plus pull. So, okay, so to start with, we're going down from 883 allocations down to 540. That is great. And also, we're going down not as much on how much we allocate, but that's okay, I guess. We're going from 94K to 84K. So we removed 10K per allocation, per operation, which is actually pretty good. If you have high traffic in here, you will actually see the performance and the hit on the garbage collection, right? But there's actually a problem. I just noticed that I forgot something. If you don't do anything, when you get these data here, you will get either a new one, which is cool, or you will get something that has been used before. That's the point, but that might have been already initialized with things. So you need to initialize it and put it back to 0, right? So you need to initialize it back to scratch. So, which means in our case, you should do something like data.pullRequest.id equals nil. Only if the pull request is not nil. Otherwise, that will panic. You should also do it for the rest, actually. But since we're only reading that, that should be enough. So let's try if that impacts the performance at all. That should not impact the performance. 541. So, okay, so it actually allocates, because it's allocating one more integer, right? So you see that integer right there. And if you were not sure of what you're using, you should allocate, reset everything, right? So you should do something like data.action equals nil, data.changes equals nil, data.number equals nil. And actually, probably even better, even easier, you could do something like the pointer to data is going to be an empty pull request event. So basically, you're putting everything back to 0. Will that impact? Well, let's see. So actually, before we remove it, let me keep this here. This is plus reset ID. This incorrect, by the way. This technically incorrect. In our case, not really, because you will always decode what you had. But if for any reason you received a message that didn't have the pull request ID, you would actually use the one from the previous one. So that's a really weird bug. So you don't want to do that. So it's important to reset the things. What if we do this one where we reset the whole thing? Let's see. I'm assuming that's gonna be way worse. Okay, so let's see. Ouch. So fourth, this is plus full reset. So look at that. This one is incorrect, so that's important. Do not use that one because that's incorrect. This one is correct, and it's 541, which is way less than the previous one. This one is also correct, but this is more generic, where we're restarting everything from scratch. We're just resetting everything. And in that one, actually, you're reallocating everything, which kind of makes sense because this is a tree, right? So trees are not the best thing for the pool, because actually every single value that you allocate is going to be of a different type. So you're going to have a bunch of them. So this is not a great example for this. But that's the point I wanted to show, the fact that before you use the sync.Pool, you should really think about, are you going to be having a bunch of values that are around the same size and of always the same type? In this case, yes, you have that, right? You have that pull request event, but that's actually just the entry point to a whole tree with a bunch of things. So not great. Now, can we make this better? And actually we can. So let's move back to the code that I had before that is a little bit better, right? Like this one. This is the code that I said works much better because of that pull request ID is the only piece that we're reallocating, right? So that is better. So what else could we do? Well, if that's the only piece we reset, it is because that's also the only piece we use. Therefore, what if we just drop the rest, right? So what I'm going to do is get this. So I'm going to define a new type that I'm going to call a pull request, and that's going to have struct, and that's going to have the same thing as in here. So as in here. So I'm going to be copying this part, and then actually let me go to definition of pull request and get this part in here, and I want to get only the ID. That's the only one that I want to keep. So I'm gonna put that. So I'm gonna replace that with a struct, and then put this here. Okay, so now what I'm doing is I'm creating a file. I'm creating a type that is compatible with the previous one, with GitHub pull request event, but it's much smaller. So now let's do that. So what if, say, I'm going to replace pull request in here. So pull request can never be nil. So I can do this. And actually, I feel like we could also drop this one. So this is even simpler. We don't need omit empty because we're always decoding. We don't need ID in this case because the JSON package will actually also search for the lowercase version. So that is not needed. So we can do that. We do need the pull underscore request. I'm almost sure because otherwise pull request will not be found. So let's see first that this didn't break our code. No, it's still working. That's why I have unit tests. And now let's do go test bench mem. Cool, look at this. So now we went down. So fifth GitHub. So smaller type plus pull plus reset plus not reset because we don't really need any because there's no pointers in there. You could actually do, you could say data.pullRequest.id equals 0 if you really feel like it. I'd say it's not really necessary, again, because we always get a new ID in that one. It's actually compulsory because GitHub works the way it is. If it's not, it's always probably safe to say this, or even to go back to the pointer and say it's nil, so that's the default value. There's nothing in there, right? All of those things are possible. So look at this. This is actually really good, right? Like we went from 883 allocations on the first iteration that we had with a bigger value and no pool. We went down to 541 in the one where we used on still the same value with all of the things, but we're resetting only one thing, which means that the rest was really fast, basically just reused all the time, which is technically correct, but kind of dangerous, I'd say, because easily someone will start using some of the field and will forget to reset it. So not recommended. So then you need to do a full reset, which kind of drops the whole thing because this is a tree and you're removing basically all of the children, all of the leaves. So you're just keeping the root, and the root is easy to do, right? But if you make it so the value that we're allocating is much more compact. This one doesn't have any pointers or anything. So the whole thing fits in one integer. Then the performance goes, the number of allocations go really low, but still we're allocating a lot. Why is that? Well, I could try to guess, but instead what I'm going to do is I'm going to do one thing that I will continue on the next episode. I'm going to try to find where is this being allocated. How? Well, with pprof. So there's an episode on pprof, by the way, that I will link somewhere here. Also, there's a video and a workshop that I run regularly, which is Goal Tooling in Action, that I will link also here or here. Anyway, so let's try to do that. So basically you can do go test bench, all these things. You can do mem profile, so these protocol buffer and gunzip protocol buffer. Now when you do this, that generate a file, which is this pool.test and also this one. And now I can do pprof, which is one that I downloaded from github.com/google/pprof. Check it out, is much better than Go Tool pprof. I will probably do an episode next on this specific, but you can do pprof, HTTP 6060, alloc objects to say that I'm trying to find where I'm allocating the objects, and mem.pb.gz. And that didn't work. Alloc objects, there you go. Okay, so alloc objects. Let's see. Okay, and now we find where all of this is being allocated. You can see that it's actually in the scanner, in the JSON scanner. So this still allocates a lot, even though you're only keeping part of it, which kind of makes sense. You're doing string convert quote with, so basically you're still parsing a lot of things. In order to parse those things, you need to allocate new pieces of memory to fit them in there. So it makes sense. It is not really dramatic, to be honest. There's probably ways of fixing it. If you want to see it in a different way, flame graph, love flame graphs. You can see that so in our pool handle, most of the things are being allocated by the code. Also the thumb.fprintf allocates a tiny little bit, but it allocates so little that maybe you can just ignore it, to be honest. This one allocates much more, and you can see that most of the things is from decoding something here. So we saw how you can start from the simpler code, the simplest code, which is just using the full GitHub pull request event, which is the whole payload that you get from GitHub, just to code the whole thing and not pooling or anything. We saw that that was allocating a lot. So then we went down to fewer allocations by using a GitHub sync.Pool. But then the sync.Pool, as we saw, you need to reset the object before you use it. That's important because otherwise you will get previous values, which is kind of weird. And if you get issues in there, you get bugs, super hard to find. So remember, it's super important to reset them. Then that added one single allocation because that was the allocation for the ID, which was a pointer to ID, which is pretty cool, right? But if you add just in case the reset for the whole thing, then you're going back to 882, just one less allocation less than before. That allocation is actually the allocation of the root itself, the value holding all of those things. So that's not necessarily very good. But then we saw that also keeping the same idea, just the sync.Pool, but using a smaller struct and more compact because there's no pointers, everything is just one piece of memory. So all of a sudden you just have one integer. You're going down in the number of allocations because now the pool is actually holding everything together really well. The problem is that you're still decoding JSON, so that's where allocating, and that's why the number of allocations is so high, and we showed that with pprof. So yeah, that's the end of the episode. I hope you enjoyed it. Let me know what you think. If you have any questions, feel free to ask questions down here on the comments. For suggestions, form.justforfunc.com is the place to go. It's much easier than sending emails or anything like that, because I try to read all of them. It's hard to keep track, to be honest. Also, tell your friends about the series. Tell your parents, tell your children, tell everyone about it. Subscribe, like, all of those stuff. And now see you all in 2 weeks. And also, I leave you with the bloopers with Jesse and James from the beginning of the video. See you in 2 weeks.
Hide. Okay.
So my very bald head.
This might be part of the video too. Hi, I'm Franciscan Boy, and this is just... Okay, let's try that one again. Okay, let's try again.
Give us the
Let's try
mark.
again.
So it's
Okay.
I'm
Franciscan Boy, and this is just... Yeah, you come back, and this is just for fun. Okay.
Right? Was I right or not?
No, you were not.
No, you
not
were
right.
definitely not.
Wait, when did we come up there?
So as soon as he says,
Hi, I'm
boy,
Franciscan Boy. You come up,
Yeah.
and this is just for fun.
and this is just for fun. Fuck, that's hard to
Okay.
remember.
Hi, I'm Franciscan Boy,
And
and this is just for fun. Okay, let's do it once more where you actually say it. Just like, hi, I'm Franciscan Boy, and I'm Jesse Frelzel, I'm trying. Like, that's not the same. Okay. Hi, I'm Franciscan Boy,
And
and this is just for fun. Perfect, okay.